Hello guys, and welcome to the next video lesson. This is 3.3, Proving Lines Parallel. And this is part of our chapter on parallel and perpendicular lines. So to get started, guys, we're going to be going over the converse of all the postulates and theorems that we talked about in the previous lesson. So we know anytime you have a set of lines that is intersected by a transversal, you do create these four angle pairs, corresponding angles, alternate interior angles, same side interior angles, and alternate exterior angles. And we also learned in the previous lesson that when the lines are parallel, we learn the relationships between those four pairs of angles. Well, now we're going to talk about the converse of those theorems and postulates. So the first one is a postulate, and it is the converse of the corresponding angles postulate. We have, if two lines intersected by a transversal form corresponding angles that are, you got it, congruent, then the lines are parallel. So we're just going in the opposite order. Remember back in chapter 2 when we talked about conditional statements and the converse of conditional statements, we're just flipping it around, okay? We learned in the previous lesson, if the lines are parallel, then corresponding angles are congruent. The only thing we're saying now is if the corresponding angles are congruent, then we know the lines are parallel. And that's going to be a postulate, okay? Next up, we have a theorem. We have the converse of the alternate interior angles theorem. It says, if two lines intersected by a transversal form alternate interior angles that are congruent, once again, then the lines are parallel, once again, okay? So hopefully that is making sense to you. We are just going in the reverse order of the theorems and postulates from the previous lesson. That's all, okay? Next up, if two lines intersected by a transversal form same side interior angles that are supplementary, then the lines are parallel. Okay, so remember, same side interior were the ones that are supplementary, okay? Everything else, congruent, same side interior, those add to be 180. Let's move on. We have one more left. This is the theorem, the converse of alternate exterior angles. If two lines intersected by a transversal form alternate exterior angles that are congruent, then the lines are parallel, okay? So basically what you get from this lesson is, if the relationships work out to be true, then you can use that to prove that the lines are parallel, okay? So that means you can take the theorem in reverse order. Let's look at a few examples of these postulates and theorems in place, okay? For these four examples, we're going to use this diagram to determine which lines, if any, are parallel. And if they are, then we're going to state the postulate or theorem that justifies it, okay? So let's look at the first one. It says angle 2 is supplementary to angle 3. Let's go ahead and make those stand out. Angle 2 and angle 3 right there, okay? Now, when I have a figure that has multiple lines, multiple transversals, it's important for me to use the strategy to make my lines and my transversals stick out for me. So I'm going to highlight them like we've been doing before. I'm going to highlight the transversal that goes with these two angles that I'm talking about. And that's going to be this transversal right here. And I'm also going to highlight the interior for those, that transversal, and that's going to be here. Okay, so I'm only going to be focusing my attention in this area. The other part of the figure, I'm not going to worry about for now, okay? So if the yellow line is my transversal, and I am intersecting lines A and B, and this blue portion is my interior, then that would mean angles 2 and 3 are same side interior angles, okay? So we know that. We can identify that angle pair, same side interior, but the example says they're supplementary. When are same side interior angles supplementary? When the lines are parallel. So since these are supplementary, my answer is going to be line A must be parallel to line B, okay? Because of the same side interior angles theorem, the converse of it up here, right? So the converse of the same side interior angles theorem is what allows me to justify that A is parallel to B. All right, so let's see. I'm going to abbreviate this and do converse of same side supplementary. Okay, just kind of shorten that up. Next, we have angle 9 is congruent to angle 12. Let's start over and highlight only what's important for that example. So the first thing I'm going to do is identify angle 9 and then identify angle 12. Okay, and then I need to check and see, well, what is a transversal that would go appropriately with those two angles? Okay, and it looks like there's more than one, but let's just do this for now. Okay, let's say that's the transversal, and then of course I always like to identify the interior. Now when I look at this and I see where 9 and 12 are, they are not one of those angle pairs that we've talked about in the last two lessons, okay? They're not corresponding. They are not same side interior. They're not alternate interior, and they are not alternate exterior. But they are congruent. But they're congruent because they're vertical angles. It has nothing to do with the fact that we have a transversal and a pair of parallel lines. So we can't justify any parallel lines from 9 being congruent to 12, okay? So for that one, we're gonna put no parallel lines. Okay? Ignore the double L in the middle. All right, angle 5 is congruent to angle 10. Once again, we'll use our strategy. We will make sure we erase this information and start over and highlight what's important. So angle 5 and angle 10, right? Look where they are. What would be a transversal for those two angles specifically? And that's going to be this line right here. This line serves as a transversal. Okay. Then we highlight our interior. All right, so that's what we have. Now, what relationship do these two red angles have, angle 5 and angle 10? And if you look, they are alternate interior angles. They're inside the blue box that makes them interior, but they're on alternate positions across the transversal. So they are alternate interior angles, and we can use the converse of the alternate interior angles theorem that says if those two angles are congruent, then the lines are going to be parallel. So what lines are parallel? These two. That's going to be line L and line M. L is parallel to M, and that's by the converse of the alternate interior angles theorem. Converse of the alternate interior angles theorem. Again, I'm just abbreviating. Last one, we have angle 7 is congruent to angle 11. Let's prepare to do that example. Using my strategy, highlighting those angles first. Okay, now see where they are. are they on the same transversal being intersected or intersecting the same two lines? Like, not at all. They don't have a relationship with each other at all. There's nothing we can determine. So for that one, we're going to put no parallel lines as well. All right, and those are some examples of how you can use the converse of those theorems, okay? Let's look at a proof. Let's look at a proof, a slightly different proof than what we've done before. We've been doing two-column proofs. This is what we call a flow proof because it has a box that flows to another, that flows to another, and so forth, okay? So you do start out the same way as a two-column proof. You always start with the given, and you use information from your figure. So we have angle 1 and angle 3 are supplementary. And then that's the very first line here. Angle 1 and angle 3 are supplementary. The second line in your box is your reason. The first line in your box is your statement. So they gave us a statement, and we know the first reason is always given. Okay. All right. And then from there, we want to go down to B. We have to give a statement. They have the reason as definition of linear pair. So let's look at the figure. Do we have anything in the figure that would be a linear pair? And we know that means two angles that are on a straight line together. That's a linear pair. And if we look, angles 1 and angle 2 make a straight line, so they're a linear pair. So we can say angle 1 plus angle 2, they make a linear pair, they're equal 180, okay? Equals 180 degrees. And that's the definition of a linear pair, all right? Now we move over to C. They give us the statement. 1 and 2 are supplementary. We've got to justify that. Well, we know that anytime something adds to be 180, that's the same thing as supplementary. But how do we know that? We know that because that's the definition. That's the exact definition of what supplementary angles is. So we're going to put definition. You're going to spell that correctly, better than me. All right, so that we're going A, B, C. Now we're going to go up here. It says we need to give the statement, but the reason is supplements of the same angle, and that should say angle, and that has some other word. Supplements of the same angle are congruent. And let's think about this now. 1 and 3 are supplementary. 1 and 2 are supplementary. So that means 3 and 2 are both supplementary to 1, okay? So supplements of the same angle are congruent. That would mean 3 is congruent to 2, or 2 is congruent to 3, whichever way you say it, because they both are supplements to the same thing. They must be equal to each other. So we're going to say angle 3 is congruent to angle 2. Okay, angle 3 is congruent to angle 2. Moving on, this will be the last part of our proof. It says A must be parallel to B, which is what we were trying to prove. But how do we know that? How do we know that they are parallel just because, look, let's make this stand out, just because 3 is congruent to 2. Look at the positioning of angle 3 and angle 2, and let's see if there is a property or a theorem or a postulate from this lesson that will tell us that when these two particular angles are congruent, the lines have to be parallel, okay? So I see that angle 2 is in this portion of the intersection, right? It's like the top right, and then 3 is in the same spot, top right, for that intersection. That means they're corresponding. So which postulate or which theorem tells us that if corresponding angles are congruent, then the lines are parallel? we're going to use the converse of the corresponding angles postulate. Okay, so that's going to be our statement here, our reason. Converse of corresponding angles postulate. And I'm just abbreviating to save some space, okay? So that's how you would do a flow proof, proving that lines are parallel using these 4 theorems and postulate, okay? Let's move on into the practice set. I will be doing a few of the problems in this video. The ones that I do not do, you will be responsible for. If you have any questions, remember you can post those questions as a comment, or you can make sure you ask live in class, okay? The directions say, which segment or lines are parallel and justify your answer, okay? Let's look at number 2. We have here, we have a line going across, and then we have these 2 lines, which kind of look obvious to be lines cut by a transversal. I'm going to highlight that because that kind of sticks out to me. Oh, can I get my yellow? There we go. So I like to highlight my transversal yellow, and then I like to highlight the interior as blue. Okay. So I can see clearly here that this is not something where I have just straight up interior angles, because I have one right here and one right here. So what I'm picking out is that these are going to be corresponding. All right, you see this one in this position, they're in the same position. So these 2 corresponding angles are congruent. I know they're congruent because they gave me the red arcs. Okay, so these 2 angles are corresponding. So yes, we have a pair of parallel lines by the converse of the corresponding angles postulate. I do need to say what lines are parallel. So we're going to say SP, this line is parallel to TO, and that's by the converse of the corresponding angles postulate. Okay, that's number 2. All right, let's take a look at number 4. It says, find the measure of the indicated angle that makes the lines U and V parallel. All right. So we want to think about what they gave us, and then we want to think about what they're asking for. In this problem, number 4, they give us 120, and they're asking for this angle here. What's the relationship between those 2 highlighted red angles? Use your strategy if you need to. Highlight the transversal, highlight the interior, okay? Does that make it obvious to you now that these 2 red angles are same side interior? Okay, they are same side interior. And in order for these 2 lines to be parallel, we need these 2 red angles to be supplementary because it's same side, okay? So we want 120. We need 120 plus the question mark to equal a 180. Okay, and then you just solve this little equation. 180 minus 120, the question mark needs to equal 60 degrees in order for this to be a pair of parallel lines, okay? So the answer is 60. Let's take a look at number 6. We're going to do the same process. What did they give us? 105 degrees. What are they asking us to find? The angle right here, okay? Highlight your transversal. Highlight the interior so that we can decide what kind of angle pair we're talking about here. And now that I've followed my strategy, it is clear to me that these 2 angles are alternate interior angles, okay? And then we also know in order for the lines to be parallel, alternate interior angles have to be congruent. They have to be equal to each other. And so the question mark is just going to be 105 degrees. Okay, as our answer for number 6. Moving on. We have one more here. We have question 8. It says, find the values of x that will make lines U and V parallel. So this time, just like the ones before, but this time we're solving for x. Okay, highlight was given 100 and x plus 111. Use your strategy, highlight your transversal. Identify the interior. Okay, and we see here these two red angles are alternate interior angles. We also know that alternate interior angles have to be congruent when the lines are parallel. So 100 equals x plus 111. And now we are solving this equation for x. We can simply subtract 111 on both sides. And x will equal -11. That's what x needs to be in order for these lines to be parallel. Okay, that is it for this lesson, guys. We will see you in the next one.